Hello, viewers. In today's session, we are going to discuss another important problem from derivatives, right? So here we are given the equation of a curve that is tan inverse x square plus tan inverse y plus tan inverse x square y is equal to 7 pi over 12. Then we have to find the slope of the tangent to the curve which is given by this equation 1 at x is equal to 1, right? So in this problem what we have to do, we have to find the slope of the tangent to the curve which is represented by this equation 1 at x is equal to 1. So now we know that if we have a curve, say y is equal to f of x, then the slope of the tangent to this curve at some point, say x1 comma y1, is given by the derivative of y with respect to x at this point, right? So the slope of the tangent is given by a dy over dx at this point x1 comma y1, right? And here we are given that x1 is equal to 1, so it implies that we have to first find the value of y1, right? So the derivative dy over dx at x1 comma y1 represents the slope of the tangent to the given curve, right? So to get the derivative, let us first find y1 by taking x1 is equal to 1 in this expression, right? So this equation is satisfied by the point x1 y1. So now we have tan inverse x1 square plus tan inverse y1 plus tan inverse x1 square and y1, and this is equal to 7 pi by 12. So x1 is 1, so we have tan inverse 1 square plus tan inverse y1 plus tan inverse 1 square, because x1 is 1, and here we have y1, and this is equal to 7 pi by 12. So now 1 square is 1, so we have tan inverse 1, then here we have tan inverse y1, and this is 1 square 1, 1 times y1 is y1, so we have tan inverse of y1, and this is 7 pi by 12. So these two terms get added, and tan inverse 1 is pi by 4, and here we have 2 times tan inverse of y1, and here we have 7 pi by 12, and taking this term, that is pi by 4, to the right hand side, we have 7 pi by 12 minus pi by 4. Now simplifying this term, we have 12 as the LCM. Here we have 7 pi, here we have 3 pi. So this is 4 pi by 12, that is equal to pi by 3, right? 4 times 3 is 12. So we have 2 times tan inverse y1 is equal to pi by 3. So tan inverse y1 is equal to pi by 6, right? So we have taken this 2 to the denominator. We have pi by 6. So y1 is tan pi by 6. This is tan 30 degrees, which is equal to 1 over square root of 3. So now we have obtained the value of y1 as 1 over square root of 3, right? So the point is now x1 y1, which is 1 comma 1 over square root of 3. So now we have obtained the coordinates of the point where the slope of the tangent is to be calculated. So now let us differentiate equation 1, both sides with respect to x, right? So we have d by dx of tan inverse x square plus tan inverse y plus tan inverse x square y, and here the derivative of 7 pi by 12 is equal to 0 because this is a constant, right? So d by dx of this quantity is now equal to 0. So what we'll do, we'll do the differentiation term by term. So first we have to differentiate tan inverse x square, right? So the derivative of tan inverse x square is given by 1 over 1 plus x square whole square here, and then by chain rule we have to find the derivative of x square, right? So here we have used the result, that is the derivative of uh, tan inverse x is equal to 1 over 1 plus x square. So here we have x square, so we have replaced this x by x square here, then we have x square whole square, and then by chain rule the derivative of x square with respect to x, right? So here we have 1 over 1 plus x raised to 4, 2 times 2 is 4, and the derivative of x square is 2x. So we have 2x over 1 plus x raised to 4. So the derivative of tan inverse x square is given by 2x over 1 plus x raised to 4. So similarly, the derivative of tan inverse y is given by 1 over 1 plus y square, because first we differentiate y with tan inverse y with respect to y, and then by chain rule we have here dy over dx, right? So the derivative of tan inverse y with respect to x is 1 over 1 plus y square dy over dx. Now let us differentiate d by dx of tan inverse x square y. So first we have the derivative of tan inverse x square y with respect to x square y. So that is 1 over 1 plus x square y whole square, and then by chain rule we have d by dx of x square y. So now we can write 1 over 1 plus x raised to 4. Here 2 times 2 is 4. Then we have simply y square, that is y square. And to get the derivative of x square y, we have to make use of the product rule. So if we have two functions u and v of x, then the derivative of the product of u and v is given by a u derivative of v, then we have v and derivative of u. So here we can take u as x square, so we have x square, then derivative of v, that is y, with respect to x, then we have y derivative of x square with respect to x. So this is 1 over 1 plus x raised to 4 y square, and here we have x square dy over dx plus this is 2x derivative of x square with respect to x, so we have 2xy, right? So we have obtained the derivative of tan inverse x square y with respect to x, right? So now substituting these three values in this equation, we get, so we have now the derivative of tan inverse x square as 2x over 1 plus x raised to 4. plus the derivative of tan inverse y, which is 1 over 1 plus y square dy over dx, and then the derivative of tan inverse x square y as this expression. So we have 1 over 1 plus x raised to 4 y square, and in the bracket we have x square dy over dx plus 2xy, right? And here we have this expression equal to 0. So now to get the slope of the tangent to the curve, at this point x1 y1 is equal to 1 comma 1 over square root of 3. So let us substitute here x1 y1. So we have 2x1 over 1 plus x1 raised to 4 plus 1 over 1 plus y1 square and dy over dx, and this dy over dx is the slope at this point x1 y1, and then we have 1 over 1 plus x1 raised to 4. Here we have y1 square, and then we have x1 square dy over dx plus 2 x1 y1 is equal to 0. So 2x1, now x1 is 1, so we have 2 times 1, 1 plus 1 raised to 4. Here we have 1 over 1 plus y1 square. Y1 is 1 over root 3, so the square is 1 over 3. Here we have dy over dx, and then 1 over 1 plus x1 raised to 4 is simply a 1 raised to 4, and here we have 1 over 3. Then we have 1 square dy over dx, and here we have 2 times 1 over square root of 3, that is equal to 0. So now we have here 2 over 1 plus 1, that is 2. Then here we have 1 plus 1 over 3 is 4 over 3. And taking 3 to the numerator, we have 3 over 4 dy over dx. And here also we have 1 plus 1 over 3, that is 4 over 3. Then taking 3 to the numerator, we have 3 over 4, and then we have simply here dy over dx plus this is 2 over 3, and this is equal to 0. So now this is simply 1. This is 3 by 4 dy over dx plus 3 by 4 dy over dx, and this is 3 by 4 times 2 over square root of 3, that is equal to 0. So we have 1 plus we can add these two quantities. So we have 2 times 3 over 4 dy over dx, and here this is 2 times 2 4, that is 3 over 2 root 3 is equal to 0, and here we have 2 times 2. So now we can write 1 plus 3 over 2 dy over dx plus here we can rationalize. So we have 3 over 2 root 3 times root 3 over root 3. So this is 3 root 3 over 2 times 3. So 3 and 3 get cancelled. So we are left with root 3 over 2, that is equal to 0. Now multiplying this equation throughout by 2, we have here 2, then we have 3 times dy over dx, and here we have square root of 3, that is equal to 0. So now we can rearrange the terms. So we have 2 plus square root of 3 plus 3 dy over dx is equal to 0. So 3 dy over dx is equal to minus 2 plus square root of 3. So taking this term to the right hand side, we have now dy over dx is minus 2 plus square root of 3 over 3, right? So this is the slope m of the tangent to this curve at this point, that is 1 comma 1 over square root of 3, right? So the slope m is given by dy over dx equal to negative of 2 plus square root of 3 over 3. Hello viewers, in today's session we are going to discuss another important problem from derivatives. And here we have this problem in which we are given a function h of x which is equal to f of x raised to 10 divided by f of x, where f of x is a differentiable function in this interval 0 to infinity, right? And further we are given this condition f of 1 is equal to f prime of 1 is equal to 1, then we have to find the value of the derivative of h of x at x is equal to 1, right? So we have to find the value of h prime of x at x is equal to 1. It implies that we have to find h prime of 1, right? So what we will do, we'll differentiate this function h of x with respect to x, right? So here we'll make use of the chain rule and the formula for finding out the derivative by using quotient rule, right? So let us start. So let us differentiate both sides with respect to x. So we have d by dx of h of x, which is h prime of x, and here we have d by dx of f of x raised to 10 divided by f of x, right? So what we will do here, we'll first find the derivative of f of this quantity, right? And the derivative of f with respect to this quantity is f prime of x raised to 10 divided by f of x, and then by chain rule we'll differentiate the quantity x raised to 10 divided by f of x, and using the quotient rule, right? So the quotient rule goes like this: if we have two functions, say u and v, and these two functions are functions of x, so the derivative of u over v is given by v derivative of u, then u derivative of v, and divided by v square, right? So here we have now h prime of x, and this is f prime of x raised to 10 divided by f of x, and here we can take u as x raised to 10 and v as f of x. So we can now write f of x using this result, and then the derivative of x raised to 10 minus we have x raised to 10 and then the derivative of f of x, right? And in the denominator we have the square of f of x, right? Okay, so now we can simplify this expression by writing f prime x raised to 10. Here we have f of x, and then we have f of x, and the derivative of x raised to 10 with respect to x is 10 times x raised to 9. So here we have used the power rule, that is the derivative of x raised to n with respect to x is nx n minus 1, right? And here we have x raised to 10, and the derivative of f of x with respect to x can be written as f prime of x. And in the denominator we have f of x, and this is square. And now the expression for h prime of x is given by this expression, right? So now we have to find h prime of 1. So what we will do, we'll take x is equal to 1 in this entire expression. So we have h prime of 1 is equal to f prime, and here we have 1 raised to 10, which is simply 1. And then we have here x is equal to 1, that is equal to f of 1. And then here we have f of 1, and 10 times x raised to 9. When x is 1, 1 raised to 9 is 1, so here we have simply 10. Then here we have 1 raised to 10, that is equal to 1, and here we have x is equal to 1, so this is simply f prime of 1, right? And in the denominator we have f of 1 square, right? So taking x is equal to 1, h prime of 1 is now equal to this expression, and here we can easily see that we have f of 1, here also we have f of 1, f of 1, and then f prime of 1, and f of 1 is equal to f prime of 1, and both these are equal to 1. So let us replace f of 1 by 1 and f prime of 1 by 1 in this expression. So now we have h prime of 1 is equal to f prime and 1 over f of 1 is 1. So here we have 1, then we have f of 1 is 1, 1 times 10 minus 1, because f prime of 1 is also 1. Then here we have 1 square, right? So now here we have f prime of 1, because 1 over 1 is 1, and here we have 10 minus 1 over 1. So f prime of 1 is equal to 1, and then we have 10 minus 1 is 9, right? So 1 times 9 is simply 9, right? So the value of h prime of 1 is equal to 9, right? So this is how we can solve these kind of problems.